Hi everyone, let's start paper 1 multiple choice questions of chemistry AS level, May June 2023, variance 12. The duration of this paper is 1 hour 15 minutes. Well, we have 40 questions in this paper and we need to attempt all of them. All right, total mark for this paper is 40. You can use the calculator in this paper. Important values, constant and standards are printed in the question paper. All right, periodic table is also provided in this paper. Let's see what we have in this paper. Question number 1 is when chlorine gas is analyzed in mass spectrometer, obviously Cl plus 35 ions are detected. All right. Which row is correct? Number of neutron in Cl 35 plus. So first of all, we should know and we should understand that the atomic number or proton number of chlorine is 17. And the mass of this chlorine is 35, which means it has 17 protons, which means it has 17 electrons, and 35 minus 17 becomes 18 neutrons, I believe. All right. So 35 minus 17, you will get neutrons. Okay. Now we have Cl plus. That means proton number and nucleon number will remain same. So we have same number of protons, but because of plus charge, we have 1 electron is lost, which means out of 17, we have 16 electrons now. 1 electron is lost, and we have 18 neutrons, obviously. So number of neutron is 18. So this and this might be the right answer. Obviously, A and B is incorrect option. We have 16 electrons. Let's configure this because electronic configuration of Cl plus examiner is talking about. So 1s2, 2s2, 2p6, 3s2, and 3p4. Let me check. We can find this configuration: 1s2, 2s2, 2p6, 3s2, 3p4. So this might be the right answer. So obviously, answer is going to be C. All right, that's an easy question. By the way, one more thing. This 35 is the nucleon number, with 17 is the proton number. Okay, and nucleon number is basically the sum of protons and neutrons in the nucleus. You should remember all these. Which species is the free radical? We have discussed free radical in the class. A species having odd electron. Odd electron can be 1 or more than 1. Species having odd electrons or single unpaired electrons. Okay. Helium has an atomic number of 2, which means it has 2 electrons, which means configuration is going to be 1s2, which means it has paired electron in s orbital. So we need an unpaired electron, which means option is incorrect. Beryllium has an atomic number of 4, and the negative charge on it indicates that it has total 5 electrons. So configuration, let's do the configuration: 1s2, 2s2, and then 2p1. 2p1 means that it has 1 unpaired electron in the 2p orbital, which means it has an odd number of electron in p subshell, which means beryllium could be the right option. Let me discuss option C and D. Oxygen has an atomic number of 8. 2 minus charge indicate that is it has total 10 electrons, which means configuration is going to be 1s2, 2s2, and 2p6. All of them are fulfilled. Which means option is incorrect. Zinc has an atomic number of 30. Let's configure this. In place of 10 electrons, we can write neon. Then we have 3D. Then we have 4s. 4s contain 2. So, sorry. My bad. This is going to be argon instead of neon because we have 30 electrons. So, argon shows 18 electrons. 18 and 2, 20. So, 3D contains 10 electrons. Again, all of them are fulfilled, which means D is also incorrect. Okay. Which statement is correct? the first ionization energy of chlorine is more than the first ionization energy of argon. Absolutely incorrect, because it has to be less than. Why? Because in class I have told you that argon is a noble gas and all noble gases exhibit stable configuration and follow the octet rule, which means they are extremely stable, and the removal of electron from any stable element is not easier, which means more energy is needed for ionization. Consequently, all noble gases have higher ionization energy than other elements, which is why chlorine has the lower ionization energy than argon, and therefore option A is incorrect. Let me discuss the second option. The second ionization energy of calcium is more than the second ionization energy of magnesium. Okay. Second ionization energy. Second ionization energy of calcium is more than magnesium. Obviously, it's incorrect. Why? Because down the group, ionization energy decreases because of the increase in the shielding effect, which means calcium is lower than magnesium, and therefore its ionization energies should be lesser. Okay. And also, calcium has calcium found in period 4. So it has 4 shells. Magnesium is found in period 3, so it has 3 shells. Which means calcium has more number of shells. So if it has more number of shells, then it means it has weak nucleus to electron attraction. So electron removal from calcium becomes easier, which its ionization energy should be lower than that of magnesium. Okay. So obviously B is incorrect also. Let's talk about C. The second ionization energy of sulfur is equal to the first ionization energy of phosphorus. The second ionization energy of sulfur. So examiner is talking about this thing. Now, one electron is removed from the gaseous monopositive ion of sulfur. It will turn to 2 plus an electron, which means this sulfur ion has 16 protons and 15 electrons. No. This ion has 16 protons and 15. My God. 15 electrons. On the other hand, let's talk about phosphorus. This is gaseous this is gaseous neutral atom. When we remove one electron from its valence shell, it's going to be gaseous monopositive ion. Now this has 15 protons and obviously 15 electrons. C, it has more protons than electrons, so it has a stronger nucleus to electron attraction as compared to phosphorus. So ionization energy cannot be equal, it should be different, right? It should be greater than phosphorus. So cannot be equal, because sulfur has more protons than electrons, which means this ion has more stronger nucleus to valence electron. So electron removal from this ion becomes difficult, so more energy is needed for ionization, which means this ionization energy of sulfur cannot be equal to the first ionization energy of phosphorus. So option C is also incorrect. Obviously, if A, B, C incorrect, right answer is going to be D. Let's read the D. The 8th ionization energy of chlorine is more than the first ionization energy of neon. That's right, because chlorine has more protons than electrons, which means chlorine has a stronger nucleus to electron attraction as compared to neon, which is why more energy is needed for ionization, and therefore ionization energy, or 8th ionization energy of chlorine, is greater than the first ionization energy of neon. I can write this in this format. Wait. I can write this like this. This is chlorine 7 plus. For 8th ionization energy, it's going to be 8 plus and an electron, right? So it has 17 protons and 10 electrons. Whereas in neon, this is the first ionization energy of neon. It has 10 protons and 10 electrons, right? So it has 10 protons and 10 electrons, whereas it has 17 protons and 10 electrons, which means over here, the nuclear charge or nucleus to valence electron attraction is stronger as compared to this one, which is why 8th ionization energy of chlorine is greater than that of neon, because electron removal from this ion is extremely difficult. So we need more amount of energy. I hope it makes sense to you. Next question is, when one mole of hexane is an alkane, combust in an excess of oxygen. That means it is a complete combustion. All right. Then how many moles of products are formed? Products. So examiner is talking about carbon dioxide and water, the total number of moles of carbon dioxide in water. So hexane is an alkane, and hexane has a formula of C6H14. In the presence of excess oxygen, it will turn to carbon dioxide and water, the 6 moles of carbon dioxide and 7 moles of water, because we have 6 carbon atom here, so we need to put 6 here. We have 14 hydrogen atoms, so I'll put 2 here. Now, how many moles of carbon? 6. How many moles of water? 7. 6 plus 7 is going to be 13. So C is going to be the right answer. That's a very straightforward question. Question number 5. Separate samples, each of mass 1 gram of the compound listed, are treated with an excess of dilute acid. Which compound releases the largest amount of carbon dioxide? Releases the largest amount could be in terms of mass, could be in terms of volume of gas. So I believe first we need to find out the MR of all the substances, because given mass is given, because given mass is already there in the question. So I think the MR of calcium carbonate is 100.1. The MR of lithium carbonate is 74. The MR of magnesium carbonate is, I believe, 84. And the MR of sodium carbonate is 106. Okay. So what we can do is, a mass of sample, which is 1 gram, which is given in the question, guys, divided by the MR, which is 100.1, you will get moles of calcium carbonate. And since molar ratio between calcium carbonate and carbon dioxide is same, so obviously you will get the same number of moles. So into 24 dm3. So you will get moles if you divide these two values. Now 1 mole equals to 24 dm3. Whatever you will get from this fraction, you need to multiply the volume by 24, molar volume. Right? So it's 1 over 100.1 into this. So you will get 0.24 dm3. Similarly, 1 divided by 74, you will get moles of lithium carbonate. Since lithium carbonate and carbon dioxide has same molar ratio according to the equation, which means if 1 mole equals to 24 dm3, so this moles gives you how much volume? So we need to multiply by 24. you will get how much? 0.32 dmq. Now 1 gram of magnesium carbonate, let's divide it by its MR, which is 184. You will get moles. Now moles should multiply with molar volume, which is 24. You will get volume in this scenario. You will get 0.28 dm cube, 0.28, 0.32. Last but not least, sodium carbonate. So 1 divided by 106, you will get moles. Now these moles multiply by molar volume, which is 24. So you will get how much? It's 0.226 dmq. So largest amount among these options has to be in B, which is why B is going to be the right answer. Okay. You can find the largest amount in terms of mass of carbon dioxide, but concept never going to change, and option B will remain same. Okay. Question number 6, which is statement about this molecule is correct? First of all, let's talk about this molecule. Cl and double bond O. Nitrogen belongs to group 15 of the periodic table, so it has 5 valence electrons. Let's distribute these 5 electrons in the valence shell: 1, 2, 3, 4, 5. In order to find the hybridization, this double bond needs to consider as a single bond. So how many bond pair around nitrogen atom? 2. This one is first, and this one is going to be the another bond pair. So total number of single bonds around nitrogen atom would be 2. We have 1 lone pair, so total is going to be 3. Draw 3 lines. First line always represents s orbital. Remaining 2 line represents p orbital. The hybridization is going to be sp2. So whenever you have 2 single bond and 1 lone pair with sp2 hybridization, geometry is going to be non-linear or band shape like this. And obviously angle is going to be 117.5 degrees. And we know when the geometry is band shape, molecule is always polar, because they cannot cancel out with they cannot cancel out their dipole moment. Molecule is polar because net dipole exists, just like water molecule. Let's talk about the option. Okay. Each molecule contain 1 sigma and 2 pi. Obviously, it's incorrect. We have 1 double bond, so we have 1 pi and 2 sigma in this case. So it must be 1 pi and 2 sigma. Okay, the option is incorrect. Let's talk about B. It is a non-polar molecule. It is polar because it has a band-shaped geometry. So it's incorrect. Next is, it is a linear molecule. No, it has a band-shaped geometry. It is not linear. The nitrogen atom is sp2 hybridized. Yes, it is sp2 hybridized. So right answer is D, I believe. Okay. I hope it makes sense to you. Question number 7, which row is correct? Now we have molecules, we have shape, and the total number of pairs of electrons. Pair of electrons. Any shared pair of electrons. Shared pair of electrons and total number of covalent bonds involved in the bonding is the same. So the total number of bond and the shared pair of electron is the same thing in the valence shell of central atom. Okay, let's talk about option D first. We have PF5. Its geometry is octahedral. This geometry is incorrect, which means option D is also incorrect. Why incorrect? Because PF5 has trigonal bipyramidal geometry, just like PCl5. All right. Ammonia has Incorrect shape. It is not regular tetrahedral. It is trigonal pyramidal. So this is also incorrect. Carbon dioxide has a linear geometry, which is right. Now the total number of pairs of electron in carbon dioxide, let's make the structure of carbon dioxide. It has a linear structure in which it has two double bonds, right? So how many bonds we have? 1, 2, 3, 4. So how many total number of paired electrons? 1, 2, 3, 4. 4 pair of electrons, right? It is saying 2 pair. Which means option A is incorrect, and therefore B is going to be the right answer. BF3 has trigonal planar because it has sp2 hybridization. It has only 3 single bond and a 0 lone pair. So hybridization obviously is going to be sp2. And whenever it has 3 single bond, which means it has 3 shared pair of electrons, which is also right. B is going to be the right answer. Okay, the volume of a vessel is this. This volume is already exists in meter cube, so we don't need to go for conversions. It consists of pure argon. Argon has an AR of, I think, 40. Let me check with the periodic table. 39.9 actually. Okay, it's okay. 39.9. Fine, no issue. AR is basically 39.9 at a pressure of this. So again, this pressure is given in Pascal, so we don't need to go for conversion in this case. At a temperature of 25 degrees Celsius, since temperature is given in degrees Celsius, we need to convert it into Kelvin, and for that we need to add 273 in it. So 25 plus 273 is going to be 298 Kelvin. Under these conditions, it can be assumed that argon behaves as an ideal gas. Which mass of argon does it contain? So I need to find out the mass. So I need to apply the PV equals to nRT general gas equation. Okay. Pressure is given, which is 1.00 into 10 to the power 5 Pascal. Volume is also given, which is 1.20 into 10 to the power minus 3 equals to moles. Moles is always basically mass upon AR. And this is going to be R. R is 8.31. Temperature is 298. AR is basically 39.9. Okay, 39.9. And mass is basically we need to find out. So mass from this, mass of argon is going to be 1.93 gram. So 1.93, actually B is going to be the right answer. Okay. Question number 9. A student makes 25 cm cube of 4 mole per dm cube hydrochloric acid. Let's find out the moles of HCl first. We know the concentration, we know the volume. Okay, not here actually. Let me calculate moles of HCl here. .0 into 4.00 divided by 1000. So you will get how much moles? 25 into 25 into 4. My goodness, divided by 1000. So it's going to be 0.1 mole. With an equal volume of 4 mole per dm cube sodium hydroxide, which means over here I'm using 25 cm. All right. So since the concentration and volume is same in both the cases, which means they have same number of moles. So moles of NaOH is also 25.0 into 4.00 divided by 1000. So you will get moles. Now HCl and NaOH both have same number of moles. So we can use any value from these two, all right? The initial temperature of both solution was 15 degrees Celsius. So T1 was 15 degrees Celsius. The maximum temperature reached was 30 degrees Celsius. So T2 is basically 30 degrees Celsius. So by using these two values, I can find the delta T. So delta T is basically 15 degrees Celsius. 30 minus 15 is going to be 15 degrees Celsius, right? And 1 degree Celsius is always equals to 1 gram, which means 15 degrees Celsius equals to 1 degree Celsius equals to 1 Kelvin. So 15 degrees Celsius equals to 15 Kelvin. So we don't need to convert it into Kelvin because it's a change in temperature. Okay. Now in the next part of the question, the heat capacity of the final solution is this. So we have C. This is C. This is a specific heat capacity. Use this result. What is the enthalpy change of the neutralization of hydrochloric acid? That's easy. First of all, apply delta Q equals to MC delta T. Oh, yes. One more thing. How much mass? The volume of solution equals to mass of solution, because 1 cm cube is always equals to 1 gram. So in total, we have 25 cm cube plus 25 cm cube. So it's going to be 50 cm cube. And since 1 cm cube equals to 1 gram, so it's going to be 50 gram. So mass is 50 gram. Specific heat capacity is 4.18. Delta T is 15. So delta Q, 50 into 4.18 into 15 is going to be 3135 joules. Let's convert it into kilojoule by dividing 1000. 3.135 kilojoules, right? This is my first step. Second step is moles of HCl and NaOH both are same, which means I can take any value. Examiner is talking about the enthalpy change of neutralization of HCl. So HCl has 0.1 mole. So if you have 0.1 mole of HCl, it gives you 3.1, my bad, 3.135 kilojoules energy. So if we have 1 mole, because enthalpy change of neutralization is always applicable for 1 mole. So 3135 divided by 0.1 is going to be 31.35 kilojoules per mole. Since it is a vector quantity, and you know that neutralization is an exothermic process, we need to put negative sign here. That's going to be minus 31.4 kilojoules per mole. So let me check minus 31.4 minus 31.4. So B is going to be the right answer. Okay. Oh my goodness. Question number 10. Oh my goodness. Nitrogen monoxide is rapidly oxidized to nitrogen dioxide. Okay. The equation is given. Now the next is nitrogen dioxide can then dimerize to form nitrogen tetroxide. Okay. And its delta H value is also given. The HF of NO and NO2 is also given. What is the value of the standard enthalpy change for this reaction? So we have two things. First, we need to make NO2, and then from NO2, we need to make N2O4. So this is my first step. This is my second step. And we need to find out the delta HR for this. Okay. can I use another page, or I can accommodate my answer in this? Let's find out the next page. Let's solve this question on the next page, so that, because this question is extremely different and what we have discussed in the classes. So let's do this here. Okay. So first is, let's find out the energy of this equation, because equation for this energy is not given. Let's find out the delta HR. Let me read it. 2 NO plus O2 arrow 2 NO2. We need to find out the delta H value for this reaction. How? Because HF of NO and HF of NO2 already given in the question, which means I have to start from the constituent elements. So I need to make the bond, I need to make the Haseloff cycle. And since formation data is given, so we need to start it through constituent elements. All right. That's what we have discussed in the class. The value of NO is given, which is plus 91, multiplied by 2, because we have 2 moles in the equation. The standard enthalpy change of formation of NO2 is already given, which is plus 34. So we need to multiply by 2 because we have 2 moles in the equation. What we can do is, okay, we can make clockwise arrow in the cycle. This arrow and this arrow matches the clockwise direction, which is why both these values taken to be positive, and this value has to be the negative one. So let's arrange the values. Delta H is plus 91 times 2 minus plus 34 times 2 equals to 0. Then delta H equals to delta H plus 182 minus minus 68 equals to 0. Then delta H is plus 114 equals to 0. Then delta H equals to minus 114 kilojoules per mole. Okay. So I've got the value of this. Now I need to find out the delta HR for this reaction. So what is the second step? This is my first step. In the second step, make the equation 2NO plus O2 arrow N2O4. Now we need to find the delta HR. So see, NO is converting into NO2 first. So NO is converting into NO2 in this equation. All right. And this equation, NO is converting into NO2. I'm in this equation, and we have got the value which is minus 114. Minus 114. And then NO2 is converting into N2O4 according to this, and its value is already given, that is minus 58. Okay. Now arrange the arrow. Since I'm going from this side to that side, so let's make the arrow in this direction. It doesn't make any difference whether you need to write in this direction or in the opposite direction. So these two values taken to be positive. So let me arrange the values here. Delta H R plus minus 114 plus minus 58 equals to 0. Okay. So delta HR minus 114 minus 58 equals to 0. Then delta HR minus Minus 1 is plus 172 equals to 0. Then delta HR equals to minus 172 kilojoules per mole. So the enthalpy change of reaction for this equation is going to be minus 172 kilojoules per mole, and therefore D is going to be the right answer. Okay, I hope it makes sense to you. D is going to be the right answer. All right, guys. Okay, now the question number 11 is lithium aluminum hydride, which is basically a reducing agent, contain aluminum hydride ions, and this aluminum hydride ion has a tetrahedral geometry with an hybridization of sp3, all right, with an angle of 109.5 degree, in which aluminum has an oxidation state of +3. All right, so aluminum is +3 in this situation. Lithium aluminum hydride reacts with water as shown. Okay, so it is hydrolyzing with water, converting into hydrogen gas, lithium hydroxide, which is your alkali, and aluminum hydroxide. Okay, in this reaction, each of the 4 water molecules produces 1 hydroxide ions. It does this by losing 1 hydrogen ions, which reacts with the lithium aluminum hydride. Which changes in oxidation number occur in this reaction? So first of all, in this compound, in this, lithium is +1 because it is found in group 1 of the periodic table, so it has a charge of +1. Aluminum has a charge of +3, and hydrogen has a charge of, again, +1. Oxidation state obviously in this compound is going to be different. Let me calculate the oxidation state of hydrogen in this complex. Let me calculate. For instance, hydrogen is 4x. Lithium belongs to group 1, so it has +1 charge. Aluminum has a charge of +3 because it is found in group 13 of the periodic table, equals to 0. Then x equals to -1. Okay, so oxidation state of hydrogen is basically -1 in this scenario. -1. Then oxidation state of hydrogen is -1 in lithium aluminum hydride. Over here, the charge of lithium is +1. The charge of aluminum is again +3. And the charge of hydrogen is again +1. All right. The charge of oxygen in water is going to be -2. And the charge of oxygen here is also -2. Over here, hydrogen is 0. So if we look at the situation here, I can cancel lithium on both the sides because lithium oxidation state will remain same in the entire reaction. Oxidation state of aluminum, charge of aluminum on both the sides will remain same, cancel out. Oxygen charge will remain same on both the sides, cancel out. So hydrogen is basically here is +1. And over here, the oxidation state of hydrogen is -1. So from here to here, that is the increase in oxidation state, which means it is oxidation. And this oxidation is increased by 1. Increases by 1. Over here, it is going to be +1 to 0, which means decrease in oxidation state. Let me change the color. From here to here, it's +1 to 0, which means decrease in oxidation state, and decreases and obviously decreases by 1 because it's plus 1, and it is 0. That means it must be minus 1. Decreases by minus 1. Okay. So let's talk about the option. Aluminum increases by 1. No, aluminum oxidation state on both the sides will remain same, which means option A is incorrect. Uh, Oxygen decreases by 1. Oxygen oxidation state will remain same on both the sides. So obviously it's incorrect as again. Hydrogen decreases by 2 and also increases by 1, not decreases by 2. So B is incorrect, and therefore C is going to be the right answer because it increases by 1 and decreases by 1. So that's the only conversion I have seen in this equation, which is why from my perspective it's going to be C. Question number 12. The vanadium salt VOSO4 is soluble in water and reacts readily with powdered manganese in dilute sulfuric acid. By the way, manganese is a metal, and all metals are reducing agents. And so is magnesium. And so is magnesium. Okay, so magnesium is also a reducing agent. The equation for the reaction is shown, which a statement about this reaction is correct. Hydrogen is oxidized in this reaction. Well, the oxidation state of hydrogen is +1 here, and the oxidation state of hydrogen is +1 here, and the oxidation state of hydrogen is also +1 here, which means the oxidation state of hydrogen in both on both product and reactant side will remain same, which means hydrogen is not oxidizing, and therefore A is incorrect option. Now the next is manganese is the reducing agent in this reaction. That's the right statement from my perspective because all metals are reducing agent, which means manganese is reducing vanadium from +4 to +3, I must say. All right. So B is right answer because a reducing agent causes another substance to be reduced and oxidizes themselves, which means manganese changes its oxidation state from 0 to 2+. So manganese itself is oxidizing but reduces vanadium. So B is going to be the right answer. But let's talk about C. Sulfuric acid is the oxidizing agent in this reaction. Absolutely incorrect because we have +6 oxidation state in sulfur. We have +6 oxidation state in sulfur. We have +6 oxidation state of sulfur in this. So technically it is sulfate, it is sulfate, it is sulfate, it is also sulfate. So there is no change in oxidation state of sulfur in the entire reaction, which means sulfuric acid is not acting as an oxidizing agent. In fact, sulfuric acid is acting or is using as an acidic medium here. So C is incorrect. Let's talk about D. The oxidation state of vanadium changes from +5 to +3. Let me talk about that. So first of all, let's determine the oxidation state of vanadium in VOSO4. Let's say vanadium is X, oxygen has a charge of -2, sulfate has an overall charge of -2 equals to 0 because molecule is neutral, then X equals to +4. On the other hand, when we talk about V2SO4 taken 3, so if sulfate has 2 minus charge, obviously vanadium has in this scenario, no. In this scenario, vanadium has a charge of +3 because let me count. I'm right, it's +3, but let me give the calculation area. It's 2x minus 2 times 3 equals to 0. Then 2x equals to +6. Then x equals to +3. So basically, the oxidation state of vanadium in this compound is +4, not +5. The oxidation state of vanadium in this compound is +3. So this is the right +3 oxidation state, but cannot be +4, which is why D is incorrect. So it's basically wrong, +4 to +3. Okay. And therefore, B is going to be the right answer. All right. Question number 13. In which equilibrium will an increase in pressure, when you increase the pressure, volume decreases according to Boyle's law? And volume decreases means lesser number of moles, because if we have less moles, we have less volume. Okay. At constant temperature, that confirms the presence of Boyle's law. Increases the yield of the product. If it increases the yield of the product, then it means equilibrium favors towards right hand side. Right hand side or product side is the same thing. Okay, so let's talk about D first. We have total 4 gaseous moles here. We have 4 gaseous moles here. As the number of moles on both the sides is same, so there will be no change in equilibrium position. Therefore, D is incorrect. We have 2 moles here, and we have 2 moles here. Same scenario, we have same number of moles on both the side, both on product and reactant side, which means there will be no change in equilibrium. So C is incorrect. Now let's talk about B. This is gaseous molecule, this is gaseous molecule. So we have 5 moles on the reactant side, whereas we have 4 moles on the product side. All right. So we have more moles here, we have less moles here. So if we increase the pressure according to Lee-Shutter's principle, equilibrium favors towards right-hand side because of less number of moles. And so we'll get maximum yield in this scenario. So from my perspective, B is going to be the right answer. Let's talk about A. So we have 0 mole here. Hold on. We have 0 because it is solid. All right. It is also 0. It has 1 mole. So I cannot use effect of pressure on this situation, on this system, because for effect of pressure, the reactants and products has to be in the gaseous state. This is solid. Solids never exerts pressure, which means A is incorrect. So B is going to be the right answer. As pressure increases, equilibrium favors towards right hand side because of less number of moles or less volume. And that was the prediction I've determined initially when we have started this question. Okay. Also, one more thing. Reactants and products has to be in gaseous state for effect of pressure. Product has to be in gaseous state for effect of pressure. Okay, these 2 points you should remember about this. Okay, hydrogen iodide is added to an evacuated reaction vessel. The vessel is sealed and warm. A decomposition reaction occurs. Hydrogen and iodine are formed. Some hydrogen iodide remains. When equilibrium is established, the total pressure is 1.2 into 10 to the power 5 Pascal. The partial pressure of hydrogen is 4 into 10 to the power 3 Pascal. Hydrogen iodide, hydrogen and iodine are all gaseous under standard conditions used. So all of them are gases. Okay. What is the value of Kp for the equilibrium at this temperature, assuming the decomposition in the forward direction? Okay. It's a tricky question, I must say, because let me start. Let me do it. So we have hydrogen iodide in the vessel. It is decomposed and converted into hydrogen and iodine, all of them are gases. So at equilibrium, the partial pressure of hydrogen is this. And since hydrogen and iodine has 1:1 ratio, so if hydrogen has this much partial pressure at equilibrium, obviously iodine is going to have the same partial pressure. Oh, not minus. Not minus, it's basically 3. My bad. Now we need to find out the partial pressure of eta Hi at equilibrium. Since total pressure is given, the partial pressure of each gas, the sum of partial pressure of each gas is equal to the total pressure. So what we can do is, I have to find out the partial pressure of Hi. So what can I do is, I have the total pressure and I will subtract this. Oh, my bad. How much hydrogen here? 2. How much iodine? 2. So we need to put 2 here in order to balance the equation. So it's going to be like this. 2 what is basically the correct scenario in this situation? It's basically yes, minus 2 into 4.00 into 10 to the power 3. Okay, so this, the sum of partial pressure is equal to the total pressure. So if I need to find out the partial pressure of iodide, I have to subtract these two values. Okay, so what I'll get is I'll get 112,000 Pascal. Okay, so that's the partial pressure of Hi, which I can write it over here, 112,000. Okay, now I need to find out the value of Kp. So for that, Kp equals to partial pressure of hydrogen times partial pressure of iodine over partial pressure of Hi. And since Hi has 2 moles, so it needs to be, so Hi has 2 moles, so number of moles has to be in the power. Okay, so it must be 2 here. Now plug in the values. Partial pressure of hydrogen and iodine is same, which is 4.00 into 10 to the power 3 power square over hydrogen is 112,000 power square. So the value of Kp is going to be, let me calculate, 1.28 into 10 to the power minus 3 Pascal. So 1.28 into 10 to the power minus 3 Pascal. So B is going to be the right answer. I hope it makes sense to you. But that is the most important thing, that the sum of partial pressure is always equals to the total pressure. All right, which is why I have to subtract these two values. Now, question number 15. The equation for the two reactions are shown. The two reactions have similar reaction mechanism. The initial rate of reaction X is greater. If X has higher rate, then it means it has lower activation energy, which means it is faster since it has lower activation energy than that of reaction Y, which means it is slower. If it is slower, then it means it has higher activation energy. Okay. when measured under identical conditions of temperature, pressure, and concentration. If we are using identical conditions of all the factors, which means there will be no change in collision frequency, no change in collision frequency as the stated conditions will remain same throughout the experiment. All right. Which statement explains this difference? All right. So activation energy for reaction X is lower. Obviously, it is faster, so it has a lower activation energy. So first is going to be the right option. First is going to be the right statement. Let's talk about B. Bromine bond is weaker than chlorine bond. Since bromine and chlorine are products, so rate of reaction has nothing to do with the bond energy. And similarly, activation energy has nothing to do with chlorine and bromine because they are the products, not the reactants. We are not breaking the bonds. Actually, the bonds are forming during the reaction. So we can write second statement is incorrect because rate of reaction and activation energy has nothing to do with the products and bond energy. All right. A higher collision frequency between molecules of NOBr occurred than between molecules of NaCl. Higher frequency is not possible because the stated conditions are constant or same, which means we are maintaining the temperature, we are maintaining the pressure, we are maintaining the concentration. So if there is no change in concentration, pressure, and temperature, which means there is no change in collision frequency. So from my perspective, A is incorrect, D is incorrect, B is incorrect, and right answer is going to be C. I hope it makes sense to you. Question number 16. The diagram shows the Boltzmann distribution of energies in a gas. The gas can take part in a reaction when an activation energy EA, which is represented here, okay, the gas is maintained at a constant temperature. If gas is maintained at constant temperature, then it means there will be no change in the shape of the graph, okay? The shape of the graph changes when temperature changes. So at constant temperature, no change in the shape of graph, okay? Which statement is correct? Okay, examiner is talking about catalyst, okay? So when we add catalyst, it provides an alternative pathway. And because of that alternative pathway, it lowers the activation energy. So this must be the activation energy for catalyzed reaction. And because of that, the proportion of molecules obviously increases. So basically, and the peak, that is most probable energy, the peak of most probable energy will remain the same throughout the experiment because there will be no change in the shape of the graph. So P will be lower, wrong. P is not going to change because there will be no change in graph, so P will be remain same. So that means A and B is incorrect. Now competition exists between C and D. So when catalyst is used, obviously it provides an alternative pathway. So the activation energy moves towards left, as you have seen it. I've drawn it for you, not the right. So this one is right, this one is wrong, cannot go to the right. Yeah, cannot go to the right hand side. Yes, so C is going to be the right answer, guys. Okay. Question number 17. L, M, and N are three different elements from period 3 of the periodic table. Okay, period 3. Period 3 elements starts from sodium till argon. L is the element whose atom have 3 unpaired electrons in the 3p subshell. Oh my god. If 3 unpaired electrons are present in the 3p subshell, that means this element L belongs to group 15, and this element L must be phosphorus. Because if element belongs to group 15, so it has 5 valence electrons. Those 5 valence electrons can be distributed in the valence shell like this, S2 and P3. Now this P3 has 3 single unpaired electrons like this. I hope it makes sense to you. Okay, so that's a very powerful statement. 3 unpaired electrons in the 3p subshell. That means element belongs to group 15, and since element belongs to period 3, so it must be phosphorus. So phosphorus is L, right? Next is M is the element with the highest electrical conductivity in the period. So aluminum has the highest electrical conductivity as it contains 3 electrons in the valence shell. That's what we have discussed in the class. So this M is aluminum. So let me write it. We have aluminum, we have phosphorus. Let me talk about this. N is the element with the highest melting point in the period. Highest melting point in the period. So you should remember the melting point trend of period 3 elements, which we have discussed in the class. If you remember, this is the melting, my god, this is the melting point. Sodium to magnesium, then aluminum, then silicon. All right. Then we have phosphorus, then sulfur, then chlorine, and then argon. That was the trend I have given you. This is sodium, magnesium, aluminum, silicon, phosphorus. Phosphorus is P4. Sulfur has to be in S8. This is Cl2, and this is argon, which is monatomic. Okay. So silicon has the highest melting point. So silicon is the highest melting point, which is N. So we have aluminum, silicon, and phosphorus. Its atomic number is basically 13, 14, 15. All right. Symbol aluminum is represented by M. Silicon is represented by N. And phosphorus is represented by L. Now let's talk about which statement about element L is correct. L has a higher atomic number, that's right, as compared to M, and a lower atomic number than N. No, L has a higher atomic number as compared to both M and N. So this must be the incorrect option. This is right, but this is incorrect because its atomic number is greater than both M and N. Okay, let's talk about B. L has a lower atomic number than M. No, it has a higher atomic number than M, which means this statement is incorrect, and so option is B is also incorrect. Let's talk about C. L has a lower atomic number. No, L has a higher atomic number as compared to both M and N, which means C is also incorrect. So if A, B, C is incorrect, option is D. Right answer is D, because L has the higher atomic number as compared to both M and N. That's right. Oh, question number 18. Oh my goodness. Question number 18. Okay. In reaction 1 and 2, X represents an element in period 3. In each reaction, S is forming a product where X in its highest oxidation state. Okay. You need to consider the highest oxidation state. So first reaction, what's happening in the first reaction? Element X is reacting with chlorine, converting into this compound. Okay. And in the second reaction, element X is reacting with oxygen, converting into this compound. So which ratios show a steady increase from sodium to phosphorus? Steady increase. I'm running out of space actually, and it's tricky. What we need to do is first we need to period 3 elements. Okay. Forming a product. Okay. So let's talk about first chlorides. This is X, Y, and ClZ. Now when sodium reacts with chlorine, it is converting into sodium chloride. Magnesium, when reacted with chlorine, it is converting into magnesium chloride. Aluminum, when react with chlorine, it is converted into aluminum chloride. Silicon, when treated with chlorine, it is converting into SiCl4. Phosphorus, when treated with chlorine, it will turn to PCl3 and PCl5 both. But since examiner is talking about the highest oxidation state, so we need to disregard the PCl3 and we need to consider PCl5 in this case. All right. Now, okay, just hold on. Now, I have to discuss Y and Z, ratio of Y and Z. So it's 1:1 because we have 1 sodium and 1 chlorine. We have 1 magnesium and 2 chlorine. We have 1 aluminum and 3 chlorine. We have 1 silicon and 4 chlorine. And we have 1 phosphorus and 5 chlorine. So it's a steady increase. 1, 2, 3, 4, 5. All right. So Y and Z have a steady increase from sodium to phosphorus. All right. We need to consider till phosphorus. So that's option is incorrect. That's also incorrect. Oops. This option is incorrect. Because it's not only because we have to check this one as well. Check the first. Okay. Hold on. Let me check. Let's talk about the oxides. And for oxides, it's XpOQ. Now, when sodium reacts with oxygen, it is forming into sodium oxide, magnesium oxide, aluminum oxide, silicon oxide, and then phosphorus as P4O10. We cannot consider P4O6 because examiner is talking about the highest oxidation state. So P and Q is basically thing. Wait, hold on. P and Q. So we have to check P and Q. So ratio in sodium oxide is 2:1. My goodness, a lot of working, but no space. Simplest ratio for sodium oxide is going to be 1.5. Okay, this is P, this is Q. For magnesium oxide it is 1:1. So it's fine. 1:1. It's fine. I have to use 2 color. 1:1. For aluminum oxide, it is 2:3. So in terms of simplest ratio, it's going to be 1:1.5. Then 1:2. So it's fine again, 1:2. Then we have 4:10. So ratio is going to be divided by 4 divided by 4. So it's going to be 1:2.5, I believe. So look at this. Look at here. In the simplest ratio, between P and Q, it's a steady increase as well, right? From 0.5 to 1, 1 to 1.5, 1.5 to 2, 2 to 2.5. So in both this and this, we have a steady increase between ratios, and therefore D is going to be the right answer. Obviously, it's incorrect. Okay, I hope it makes sense to you. Question number 19. Sodium, magnesium, and aluminum, silicon, and phosphorus are all element in period 3 of the periodic table. Since all of them belongs to period 3, which means all of them have same number of shells. 3 statement about the oxides and chlorides of these elements are given. The ionically bonded oxides. Ionically bonded oxides, we have sodium oxide, which has ionic bond, magnesium oxide, which has ionic bond, and aluminum oxide, which has ionic bond. All right. These 3 are ionic bonds. Okay. Reacts with dilute hydrochloric acid. That's right, because it is basic oxide, can react with acid. Basic oxide can react with acid, and aluminum oxide is amphoteric, can react with acid. So first statement is right. Now the next is all metal chlorides produces neutral solution when added to water. That's the wrong statement, because sodium chloride gives a neutral solution of pH 7, whereas magnesium chloride gives a weak acidic solution of pH 6.2 to 6.5. If you remember the information which I've given to you, which I've given you in the class. Okay. Similarly, aluminum chloride has a pH of 3, which means second statement is wrong, because not all of them produces neutral solution. Only sodium chloride produces neutral solution. The 2 most electronegative elements form covalently bonded chlorides. The most 2 electronegative elements in period 3 would be sulfur and chlorine. And if you mix these 2, you will get SCl2, which is covalent. Molecule exhibit covalent bonding. All right, the third statement is correct. So 1 and 3 is the correct. Right answer is going to be C. Obviously, A, B, and D options are incorrect, because if second is incorrect, obviously A is incorrect. Oh, sorry. If second statement is wrong, which means A is incorrect, B is also incorrect, and D is also incorrect. Okay. Question number 20. The table compares calcium and barium and calcium carbonate with barium carbonate. Which row is correct? Reactivity of the elements with water. We know that down the group, reactivity of element increases with water. So barium technically is more reactive, whereas magnesium is less reactive. So barium is more reactive, calcium is less reactive. So C and D options are incorrect. Now let's talk about the thermal stability of metal carbonate. Guys, we have discussed this topic in such a detail that you should have an idea about this, right? So thermal stabilities of group 2 carbonates and nitrates depends on charge density, polarizing power, and distortion of electrons of anions. Since I'm talking about metal carbonate, so distortion of electrons of carbonate ions. So these are the three main factors. Okay. Now in thermal instability, down the group, ionic radius increases. If ionic radius increases, obviously charge density decreases. If charge density decreases, polarization or polarizing power also decreases. If polarizing power decreases, then it means cation cannot distort the electrons of carbonate ions easily. Hence, thermal stability increases as more energy is needed for thermal decomposition. That means that barium carbonate is more thermally stable than calcium carbonate. So barium carbonate is more stable, calcium carbonate is less stable. So right answer is going to be A. All right, let's start question number 21. Solution P and Q each contain different group 2 ions at the same concentration. Okay, one contain magnesium ion, another contain barium ion. So we have two different cations. One is magnesium ion, and the other one is barium ions. Okay. Tests are carried out on separate 5 cm cube sample of both P and Q. Okay. Test number 1. Add 1 centimeter cube of 0.1 mole per dm sodium sulfate. So if I use sodium sulfate in this case, so obviously it will turn to magnesium sulfate and it will turn to barium sulfate. According to my lecture, down the group, solubility of group 2 sulfates decreases, which means this is insoluble in water and this is soluble in water. So result in test 1, more precipitates. So more precipitate has to be with B, I mean barium sulfate, because it is insoluble in water. That means option C and D are incorrect. Let's talk about sodium hydroxide, which is our next test. So when sodium hydroxide is used, it will turn to magnesium hydroxide and it will turn to barium hydroxide. According to my lecture, group 2 metal hydroxide solubility increases from magnesium to barium hydroxide. That indicates that barium hydroxide is soluble. You will get the colorless solution. Whereas magnesium hydroxide is insoluble, and so you will get the precipitates. So more precipitates with barium ions incorrect, more precipitates with barium ions incorrect, because barium hydroxide is soluble. So obviously this is going to be the right answer. I mean B is going to be the right answer. Obviously A is also incorrect. Okay. So you need to remember two things here. Down the group, solubility of group 2 hydroxides increases and solubility of group 2 sulfates down the group decreases. Okay, so you need to remember these trends which we have discussed already in the class. Question number 22. J dissolves in water to give an aqueous solution K. Okay, K gives a dense white precipitate when aqueous silver nitrate is added. So when you will get white precipitate with silver nitrate, that indicates the presence of chloride ions. That means this solution K contains chloride ions. Okay. Whereas when we heat solution K with aqueous potassium hydroxide, so solution K gives off a gas which turns moist universal indicator blue, and this test indicates that an alkaline gas is produced. Alkaline gas is produced. If alkaline gas is produced, that must be ammonia gas. And ammonia is always formed when any ammonium ions is treated with hydroxide ions under heat. You will get ammonia and water. That's the test, that's the information which I've given to you in nitrogen and sulfur chapter, all right? And one more thing, this ammonium ion is a conjugate acid, which means it can react with hydroxide ions forming ammonia and water. So this ammonia is basically an alkaline gas. That means this solution K also contains ammonium ions. And that's the test you have done in salt analysis as well, both in O levels and in AS chemistry practicals, all right? So we have, so this J has two different ions. The first one is chloride. So we have chloride here, we have chloride here. And the second one which we have is ammonium ion. So we have ammonium ion here, we have ammonium ion here. So obviously D is incorrect, C is incorrect, B is incorrect, and right answer is going to be an A. Because when any ammonium salt react with any alkali under heat, then always ammonia gas is formed, which turns moist universal indicator paper blue. All right, that confirms the presence of ammonium ion in solution in J. Next, 23, ammonium sulfate and ammonium nitrate. First of all, let me take out the MR of ammonium sulfate. So MR of ammonium sulfate, let me calculate. MR of ammonium sulfate is basically 132, and the MR of ammonium nitrate is basically 80. Okay, are used as a fertilizers, nitrogen containing fertilizers, also called nitrogen containing fertilizers. These salts have different percentages by mass of nitrogen. Okay, they have the same effect as each other on the pH of the neutral soil. Which row is correct? Higher percentage of nitrogen by mass, which means we need to find out the percentage by mass of nitrogen in both the fertilizers. That's what you have done in O-level acid basis salt. So percentage by mass of nitrogen in ammonium sulfate is, we have two nitrogen atom in ammonium sulfate. So the AR of nitrogen is 14. We have two atoms in the formula into 2. The MR of ammonium sulfate is 132 into 100. So you will get what? You will get 21.2% by mass of nitrogen. Similarly, we need to find out the percentage by mass of nitrogen in ammonium nitrate. The AR of nitrogen is 14. We have two nitrogen atom in ammonium nitrate. So into 2 divided by the MR, which is 80 into 100. So it's going to be how much? 35%, which means ammonium nitrate has higher percentage of nitrogen by mass, which means C is incorrect, D is incorrect. Now the effect of pH on soil. Now both ammonium nitrate and ammonium sulfate has ammonium ions. So let's suppose when we talk about ammonium nitrate, it undergoes equilibrium and converted into ammonia and nitric acid. We know that ammonia is a weak base because it partly ionizes in aqueous medium, whereas HNO3 is a strong acid, and so it ionizes fully in aqueous medium. So if HNO3 is a strong acid, obviously it ionizes fully in aqueous medium. And if it is a strong acid, obviously it has a lower pH value. So lower pH value is here, lower pH value is here. So I personally feel that A is going to be the right option. Okay. And also you can say that ammonium ions are conjugate acids. So if these ammonium ions are conjugate acids, obviously the pH should be lower than 7. So pH needs to be decreases, all right? You can say in that statement as well. Now question number 24. Oh my goodness. The equation shows a reaction that occurs between carbon monoxide and nitrogen monoxide in a catalytic converter. We have done catalytic converter. In catalytic converter, we have used platinum and rhodium catalyst. Even you can use nickel catalyst, but mainly platinum and rhodium is found in the mash form in the catalytic converter. Okay. Which statement is correct? Which statement is correct? The catalyst used is finely divided iron. Not at all incorrect, because platinum and rhodium catalysts are used in a mash form. All right. Iron is used in the Haber's process, not in catalytic converter. Next is the reaction prevents greenhouse gas emission. Prevents greenhouse gas emission. Also incorrect, because carbon dioxide causes global warming and it is forming during this reaction. Look at this. So carbon dioxide is a greenhouse gas. Okay. Next, C. The reaction reduces the possibility of the formation of photochemical smog. Photochemical smog is always formed when unburnt hydrocarbons react with oxides of nitrogen. Since this oxide of nitrogen is converted into nitrogen gas, so because of the absence of NO, photochemical smog cannot be obtained, and therefore might be C is going to be the right answer. But let's talk about D. The reaction results in increased in ozone depletion. Since there is no CFCs in this scenario, which means there will be no ozone depletion in this under this reaction. So D is also incorrect. So ozone depletion always takes place through chlorine radical, which are obtained through homolytic fission of CFCs. And since there is no CFCs in this scenario, which means D is incorrect option. All right. Question number 25. Which compound has the molecular formula C6H10O? 1, 2, 3, 4, 5, 6 carbon atom we have. Let's talk about hydrogen. 2, 4, 6, 9, and this one is 10. 10 hydrogen atom and 1 oxygen atom. So this formula and this formula is, both the formulas are same, which means A is going to be the right answer. Let's talk about B. 1, 2, 3, 4, 5, 6 carbon. 3 plus 3, 9. Oh, sorry, 3 plus 3 plus 3, 9. 9 plus 3. 9 plus 3 is basically 10, 11, 12. So 12 hydrogen and 1 oxygen. It's basically incorrect because we have 10 hydrogen. Over here, we have 12 hydrogen atoms. So number of hydrogens are not balanced. 2, 4, 6, 7, 8. We have 6 carbon atoms, but we have 8 hydrogen atoms. So again, hydrogens are not balanced. Let me check again. 2, 4, 2, 4, 6, 7, and this one is 8. So yes, D. 1, 2, 3, 4, 5, 6. 6 carbon atom. Let's talk about the hydrogen. 3 plus 2, 5. 5 plus 1, 6. 6 plus 3, 9. 9, 10, 11, and then 12. So again, it has more hydrogen than the given molecular formula, which means D is also incorrect option. Okay. Question number 26. The general formula of a non-cyclic alcohol is this. How many different structural isomers? When we have N is 3, whereas N is 4. When we place N in this formula, when we have 3 in this formula, so I'll get C3H7OH. So let me make the structure. 1, 2, 3. This is propane 1-ol. And let me make like this. And this is propane 2-ol. And both are structural isomers of each other. All right. Because examiner is looking for structural isomers and different. All right. So when we put 4 in this formula, I'll get what? I'll get C4H9OH. So the first, the second, my first is 1, 2, 3, 4. This one, that is butane 1-ol. That's going to be butane 2-ol. Next is 2-methyl propane 1-ol. And the fourth is 2-hydroxy 2-methyl propane. So technically it is 1 degree alcohol. It is 2 degree alcohol. It is again 1 degree alcohol. And it is 3 degree alcohol. So we have, when N equals to 3, we have 2 isomers. When N equals to 4, we have 4 isomers. So right answer is going to be B. Okay, question 27. Compound X C5H10O3 has 1 chiral carbon atom per molecule. That's a very, very powerful statement. That 1 chiral carbon is present in the molecule. So option A is incorrect because there is no chiral carbon atom. Okay. Compound X produces bubbles of Na that indicates OH group present, alcoholic group present, not with sodium carbonate, carboxylic acid absent, COH group is absent. If COH group is absent, then it means this has COH group, this has COH group, which means B and D is incorrect, and therefore B is going to be the right answer because it has alcohol. It has 1 chiral carbon atom, this one. Okay. Question number 28. Ethene reacts with an excess of chlorine in the presence of ultraviolet light. That's called free radical substitution reaction to form a mixture of products. That's what we have done in the class. All right. How many of these products contain 2 carbon atom and 1 or more chlorine atom? Wow. That means we really need to work upon it. We really need to work on this. let me copy this to 3, 3, 4, 5. I'm running out of space. 6. My goodness. 6, 7, 8, 9. Let's start. So it must be first chlorine. Okay. And since we are using excess amount of chlorine, then it means substitution takes place repeatedly. And so in the next scenario, it might be possible that this compound has 2 chlorine atoms. Now, this issue is that each carbon has 2 chlorine. So the isomer can be like that these 2 chlorine can be present on the adjacent carbon atom. All right. So when 1 chlorine is present, there will be no possibility of isomer. But when we have 2 chlorine atoms, either they may attach to 1 carbon or they may attach to the adjacent carbon atom. All right. Now, if we have 3 chlorine atoms, the first possibility is that they can attach to the single carbon atom, or 2 chlorines attached to 1 carbon and third chlorine attached to adjacent carbon atom. What if we have 4 chlorine atoms? So 1 carbon has 3 chlorine, the other one has 1. Similarly, this can be the situation that each carbon has 2 chlorine atoms. This might be the possibility. When we have 5 chlorine atoms, then we cannot make another isomer or another possibility. What if we have 6 chlorine atoms? So that's the only possibility left, 6 chlorine atoms. So this is my first structure, first isomer. This is my second isomer. This is my third. This is my fourth, fifth, sixth one, seventh, eighth, and 9 isomers. So total 9 isomers we have. So remember, when number of chlorine atoms increases during free radical substitution reaction, the chances of the formation of isomer also increases. Like in this scenario, if 2 chlorine atoms attached to 1 carbon atom, this might be the situation that each carbon has 1 chlorine. So both of them are isomers of each other. If 1 carbon has 3 chlorine, this might be the isomer that this carbon has 2 chlorine, whereas this carbon has only 1. So on the basis of that, I have solved this whole question, and I must say that 9 is going to be the right answer. But that's extremely tough question, because in just 1 minute I won't be able to make such sort of structure in the examination hall. That's tough. When bromoethane reacts with hot ethanolic NaOH. Now, hot ethanolic NaOH indicates elimination reaction takes place. And you know that bromoethane is basically an alkyl halide with 2 carbon atoms. So when 2 carbon alkyl halide undergoes elimination, always alkenes are formed, and this alkene decolorizes aqueous bromine. That's the conformation of the gas, that alkene is formed. So when bromoethane, and I think I have done this example with you in the class. So when bromoethane is treated with ethanolic solution of NaOH under heat or heat under reflux, you will get elimination reaction, and as a result, you will get an alkene, that is ethene, because we have 2 carbon alkyl halide, so we'll get 2 carbon atom alkene. Okay, so ethene is going to be the right answer. Question number 30. Alkynes are hydrocarbons because consist of carbon and hydrogen only, and alkyl is the class of compound which contain triple bond between the carbon atom. Like alkynes takes part in the addition reaction. A saturated compound can be formed. Saturated compound means that single bond between the carbon atom exists. All right, for example, ethine reacts with an excess of hydrogen to form ethane. All right. Now, propine is C3H4, and the structure of propine is like this: CH, triple bond C, and then CH3. This is propine, CH3. How many carbon? 3 carbon, 4 hydrogen, right? Undergoes addition reaction with an excess of hydrogen bromide. Again, excess of hydrogen bromide. Okay, excess of hydrogen bromide. HBr. Then HBr in 2 stages. Okay, 2 stages is really, really important. Oh my goodness, Markovnikov rule applies to the addition of HBr at each stage. We have discussed Markovnikov rule. Markovnikov rule states that hydrogen attached to those double bonded carbons where we can have more hydrogens. In short, rich gets richer. So carbon with most hydrogen always follows the mark. And why is this happening? And why is this happening in reaction? Because of the stability of carbocations. So Markovnikov rule follows the stability of carbocations. We have discussed the stability of carbocation. Okay. So you can say, you can write that electrophile attached to those double bonded carbon atoms where we can have more hydrogens. So in this case, H is the electrophile, Br is the nucleophile. All right. So if I'll apply Markovnikov rule, obviously this hydrogen goes to that carbon atom because it has more hydrogen atom. Okay. So this is H, C, double bond C, CH3. So when I remove one pi bond, I'm going to attach one hydrogen and one bromine. Okay. First step. Now in the second step, I will continue the lecture with this product. We have one H and one bromine. Now we have, I'm using HBr in excess, so I'll use another HBr molecule. And obviously, HBr molecule we have H and Br already on the first step. Now in the second step, this is the electrophile. It goes to that carbon atom because it has more hydrogen. So this bromine goes to this carbon atom. Okay. So H is here, B is here. All right. Example is talking about the main product. That main product follows the Markovnikov rule. So main product is this. This is the main product, guys. And we need to check. This is CH3. This is CH3. This is carbon atom. This is carbon atom. This carbon has 2 bromine. This carbon has 2 bromine. This is CH3. This is CH3, which means D is going to be the right answer. Okay. Absolutely C and A is incorrect because bromines are attached to the same carbon atom. Over here, bromines are attached to the adjacent carbon atom, which is not possible. All right. Now, B is also incorrect. Although both the bromines attached to the same carbon, but these two bromines are attached to the center carbon atom, whereas these two bromines are attached to the corner carbon atom, which is not possible. All right. So let's start question number 31. In question number 31, bromine reacts with alkene by an electrophilic addition mechanism. All right, we have done this in class. By the way, when alkene undergoes electrophilic addition reaction, obviously intermediate cations are formed, and these intermediate cations will serve as an electrophile as an intermediate. Okay, which mixture will produce the most stable intermediate carbocation? So if it is asking the most stable intermediate carbocation, which means examiner is again wanted to apply the Markovnikov rule, because Markovnikov rule is all about the stability of the intermediate carbocation. Excuse me. Also, Markovnikov rule is always applicable for unsymmetrical alkene and unsymmetrical reagent. All right. So obviously B is incorrect because ethene is a symmetrical alkene. So ethene has no ethene is not unsymmetrical, which is why Markovnikov rule is not gonna apply on it. Okay. Whereas this alkene, and this alkene, all these three alkenes are unsymmetrical, which means we need to apply the Markovnikov rule, which means we need to apply and check the most stable carbocation, intermediate carbocation. By the way, 3-degree carbocation is more stable than 2-degree, and 2-degree is more stable than 1-degree. All right. Whew. Let me get the options from here. Let me decide on this page. My bad. Let me get the structure, whole question. Because there's a lot of working required on this question. I cannot accommodate my answer in that particular space. So in first option, that is in A, we have pent 1-ene, 1, 2, 3, 4, 5. 1-ene means on the first carbon we have double bond. 3 dimethyl. 1, 2, 3. 3 dimethyl. Okay. So this is the case. There are two different situations here to break a pi bond. If I'll shift this pi bond onto this carbon atom, obviously CH3, CH2, C, CH3, CH3, CH negative, and this is going to be CH2 positive. Now this carbon has positive charge with 2 hydrogen. According to my lecture, it's going to be 1-degree carbocation. In the next scenario, this might be another possibility of breaking the pi bond, that we need to shift this pi bond into this carbon atom. All right. So when I shift this pi bond onto CH2, obviously I'll get CH becomes positive now, and this CH2 becomes negative. If carbon has positive charge and it has only one hydrogen, then it means it is secondary carbocation. So this is secondary carbocation. And you know, in option A, 2 degree is more stable than 1 degree. An examiner is asking about the most stable intermediate carbocation. All right, let's talk about B. B is incorrect. Ethene gives you primary carbocation. That's the only option we have. But since ethene is symmetrical alkene, so we really don't need to apply Markovnikov rule on that. Let's talk about C, option C. C is methyl propene. Methyl propene has to be like this. Again, there are two different possibilities to shift a pi bond. Either we will shift on this carbon atom, or either we will shift onto that carbon atom. All right. So let's talk about both the shifting, both the possibilities. If I'll shift this pi bond onto CH2, obviously CH2 is going to be negative while carbon is going to be positive. And since carbon has positive charge and it has no hydrogen atom, indicating that it's going to be tertiary carbocation. Okay, when carbon has positive charge and it has no hydrogen, that means it is tertiary. Now in the second possibility, what if we shift this pi bond onto this carbon atom? Obviously it's going to be, this carbon is going to be negative, whereas CH2 is going to be positive. Now if carbon has positive charge with two hydrogen atom, obviously it's going to be primary carbocation, which is also called 1 degree carbocation. And you know that tertiary is more stable than 1 degree. That means option A is also incorrect because we have tertiary carbocation in the competition in the option. So tertiary is more stable than secondary, which means option A is also incorrect. Now let's talk about D. And again, I'm running out of space. Oh my goodness. Let's talk about D. D is propene. Propene is unsymmetrical alkene. Again, we have done propene in the class. We have done these two examples in the class. Okay. Okay, I'll try to fix it. It's very difficult for me to write in such a small space. Anyway, let's shift this pi bond onto this carbon atom. So this is going to be negatively charged, and this CH2 becomes positively charged. Obviously, if carbon has positive charge with two hydrogen atom, is going to be 1 degree carbocation. What if I'll shift pi bond onto this carbon atom? If I'll shift pi bond onto CH2, obviously this CH is going to be positive and this CH2 is going to be negative. And obviously this is 2 degree carbocation. So 2 degree carbocation is more stable than 1 degree carbocation. So look, option A and option D is incorrect because in option A, we have 2 degrees more stable than 1 degree. In option D, we have 2 degrees more stable than 1 degree. So this seems like the same situation in terms of stability, which means C is going to be the right answer because in C, we have tertiary carbocation, which is more stable than primary and secondary. I hope it makes sense to you. I hope to find it a little bit easier now. Question number 32. Halogenoalkene, which is alkyl halide, reacts with hot ethanolic potassium cyanide. The reaction mechanism is either SN1 or SN2. Remember, SN1 always takes place in 3 degree alkyl halide, whereas SN1 always takes place in 1 degree alkyl halide, and all alkyl halides are generally represented by Rx. Okay, examiner is saying which statement is correct. All secondary halogenoalkanes reacts by SN2 mechanism only is incorrect because secondary halogenoalkane can also undergo SN1 mechanism, which means A is incorrect. Okay, next is both the halogeno alkane and cyanidines are involved in the initial step in SN1 mechanism. Remember, SN1 always takes place in two steps. All right. In a step one, only alkyl halide is used. There is no nucleophile in the first step, which means option B is also incorrect. Okay. Chloroethane reacts with cyanidines by SN1 mechanism only. Again, it's incorrect. It's not SN1. It has to be SN2. Why? Because chloroalkane is 1 degree alkyl halide, and all 1 degree alkyl halides undergoes via all SN2 mechanisms undergoes via primary alkyl halide or 1 degree alkyl halide. Okay. That means B wrong, C wrong, A wrong. The correct option is going to be D. Let's talk about D. The SN2 mechanism involves a short-lived negatively charged transition state. That's the right answer. That's the right answer, because in SN2 mechanism, we have pentavalent transition state, and then pentavalent transition state has an overall charge of negative, if you remember. So D is going to be the right answer, okay? Question number 33. Y, X, and Z are 3 isomeric alcohols. Okay, separate samples of each alcohol are warmed with a mild oxidizing agent and the results noted. One of these alcohols, when dehydrated, will give a pair of cis-trans isomers with molecular formula C5H10, which row is correct? Whew. So this is 1 degree alkyl halide. Oh, sorry, this is 1 degree alcohol. This is 2 degree alcohol. And guys, this is 3 degree alcohol. How can I decide so quickly whether it's 1 degree or 2 degree or 3 degree? I've told you in the class, when OH is attached to the carbon atom with 2 hydrogen, it's going to be primary. When OH is attached to the carbon atom with 1 hydrogen, it is going to be 2 degree. When OH is attached to the carbon without any hydrogen, then it's going to be tertiary. All right. So tertiary alcohol never oxidized. Tertiary alcohol never oxidized, which means option A, option B is incorrect, because tertiary alcohol cannot react with mild oxidizing agents. So right answer is going to be C and D. I've got 50% right. All right. Which means I have to consider X and Y. Okay, let's talk about X. This is your X, CH3, CH2, CH2. Oh, I don't need to consider X because there is no X here. So I need to find out which one, which compound will give you cis-trans. So let's omit X. Let's talk about Y and Z. Let's talk about Y. CH3, CH2, CH, OH, CH2, and CH3. According to my lecture, what I've told you, when you want to dehydrate any type of alcohol, just remove the OH from the carbon atom. Once you remove the OH from the carbon atom, then obviously carbon carries positive charge. When carbon carries positive charge, obviously we need to eliminate this positive charge by removing the hydrogen atom from the adjacent carbon atom. So this is going to be the adjacent carbon atom, this is going to be the adjacent carbon atom, and you know that both these adjacent carbon atom are same. So shifting of bond, removal of hydrogen takes place from this carbon atom or this carbon atom. It doesn't make any difference. So you'll get only one type of alkene. And when you get only one type of alkene, obviously you will get CH3, CH2, CH, double bond, CH, and then CH3. So that's your pentoene. And according to my lecture, which we have discussed in the class, this pentoene gives you both cis pentoene and trans pentoene. Okay. So Y gives you cis and trans pentoene. Let's talk about Z, because Z is also very important. Okay. Let me write the structure first. This is CH3. this is C, this is OH, this is CH3, this is CH2, and this is CH3. So I need to dehydrate this alcohol, and for that, I need to remove OH from the carbon atom. Just remove OH from the carbon atom. Once, if you remove OH from the carbon atom, obviously that carbon is going to be positively charged. Now, shifting of bond, removal of hydrogen takes place from adjacent carbon atom. So this is going to be the adjacent carbon atom. And you know, these two adjacent carbon atom are same. So shifting of bond, removal of hydrogen takes place from this carbon atom or either this. It doesn't make any difference. You will get only one type of alkene from these two groups. But this is different adjacent carbon atom. Obviously, you will get different sort of alkenes from here, right? Okay. Let me make two different sort of alkenes here. What if I'll write this CH3 from red, so that I'll get the idea. Okay, I'm using shifting of bond, removal of hydrogen from this. So I'll use shifting of bond, removal of hydrogen from this carbon atom. So obviously you will get what? CH2 double bond, C, CH3, CH2, and then CH3. This will not give you any sort of geometrical isomerism because this double bonded carbon has two similar hydrogens. So if two similar atoms are grouped with the same double bonded carbon atom, you will not get geometrical isomerism. Okay. What if I go with this shifting of bond, removal of hydrogen? This is CH3. This is CH3, double bond, CH, and then CH3. So if I'll remove one hydrogen from here, and that bond will shift onto between these two carbon atoms, we can eliminate or we can remove positive charge from it. Okay. So shifting of bond, removal of hydrogen from this carbon atom, as a result, we'll get an alkene or between the carbon atom. Double bond exists. This is not going to give you again geometrical isomerism because this carbon, this double bonded carbon has two similar methyl group, which means geometrical isomerism is not possible. So Z cannot give you geometrical isomerism. So Z cannot give you geometrical isomerism. So right answer is going to be C. That's a technical question. A lot of working. Compound G gives a pale yellow precipitate with alkaline aqueous iodine. So that's called iodoform test. Iodoform test appears when two different criteria, when substances fulfills two different sort of criteria. The first one is if substance contains CH3 CH group, then iodoform test will appear. Or if compound contains CH3 CO group, then iodoform test will appear. Either this follow or that follow. I mean, from these two approaches, substance needs to follow any one of them. Option is incorrect because it has no CH3 CH OH group. Oh my goodness. Hold on. Okay. So this is incorrect because this compound has no CH3COH group. Let's talk about B. This is pentane 2-ol CH3 CH OH CH2 3 4 5. Obviously, this contains CH3COH OH group, which means B is going to be the right answer. Let's talk about C. In C, we have pentane 3-ol. Obviously, in this scenario, we will not get CH3 CHOH group. And again, we cannot get iodoform test in this scenario. Okay, there is no CH3 CHOH. Again, incorrect. Pentane 2-ol, pentane 2-ol, CH3 pentane 2 old, which means second carbon has OH. It's 2-methyl, second carbon has CH3, 3, 4, 1, 2, 3, 4, 5. Again, this compound has no CH3CH-OH group, which means this compound not going to give you iodoform test. So the D is also incorrect. Question number 35. The mechanism for the reaction between ethanol and hydrogen cyanide reacts. Start with the steps down. Okay. First of all, oxygen is more electronegative element, so it has slight negative charge. Whereas carbonyl carbon is less electronegative element, so it has slight positive charge. Then the first step, nucleophilic addition reaction takes place. So cyanide will attach to this carbonyl carbon and the pi bond shifts onto this oxygen. When pi bond shifts onto this oxygen, you will get what? You will get this intermediate anion. This intermediate anion has negatively charged oxygen. So this negatively charged oxygen not exist here because it is positively charged. It is also positively charged. It is also incorrect because both the oxygen atoms are positively charged, which means it is not the intermediate anion. Now this is intermediate anion. This is also intermediate anion, which means competition exists between B and D. B is also incorrect because cyanide has triple bond, whereas this has only 2 bonds. It has to be 3 bonds between carbon and nitrogen. So right answer is going to be D. Okay, because it has cyanide with triple bond and nucleophile reacts with electron deficient hydrogen, and so that you will get OH as the product. At the same time, CN will remove in the form of cyanide ions. Okay. Question 36. Which compound reacts with 2,4-DNPH reagent but does not react with tolerance reagent? If it is not reacting with, if it is not reacting with tolerance reagent, which means not aldehyde, which means option B is incorrect, option C is incorrect. Okay. But ketone, because this gives you positive test both in aldehyde and ketone. Since aldehyde is not an option here because it is not giving any sort of tolerance reagent test, which means B and C is incorrect. So this must be ketone, obviously. Ketone is given in A, which means A is going to be the right answer. Alcohol, option D is also incorrect because alcohol cannot give 2,4-DNPH test. Alcohol can't give 2,4-DNPH test. Cannot react with 2,4-DNPH. Okay. So this information suggests that it might be aldehyde or ketone, but this test confirms that it is not an aldehyde, but certainly ketone, which is why A is going to be the right answer. Question 37. Compound X has stereoisomers. Stereoisomers means you need to check geometrical and optical. You need to consider both. And forms a precipitate when warmed with Fehling reagent. If it is precipitate, forms a precipitate. What sort of precipitates are they? Brick red precipitates. Red precipitates of copper monoxides are formed. How about the Fehling reagent? If it is reacting with the Fehling reagent, obviously aldehyde must be present. So if aldehyde is present, then it means option B and option C both are incorrect because both of them are ketone. Now competition exists between A and D because both of them are aldehydes. So both of them will give Fehling reagent test. Both of them will give red precipitates of copper monoxide. But the issue is I need to check which one has stereoisomerism. Now option A is also incorrect because it does not have any stereoisomerism. Since this carbon is attached to two similar CH3, which means this compound cannot, this compound can't give you geometrical, and since it has no chiral carbon atom, which means geometrical and optical. Okay, so right answer is going to be D, because this is going to be the chiral carbon atom, which means it exhibits stereoisomers, and this is aldehyde functional group. It will give you Fehling test or Fehling reagent. Question 38. Which reaction will form propanoic acid? Oh my goodness, propanoic acid. Oh, okay. Acid hydrolysis of propyl ethanoate. Let me make the structure of propyl ethanoate. Propyl ethanoate. This is CH3, CO, propyl, O, CH2, CH2, CH3. That means on hydrolysis, on acid hydrolysis, I'll break this bond and you will get what? Ethanoic acid. Examiner is asking for propanoic acid, which means A is incorrect because I'm getting ethanoic acid instead of propanoic acid. Option B is also incorrect because when ester undergoes alkaline hydrolysis, obviously you will get two different products, alcohol and salt of acid. And examiner is asking for propanoic acid, not for salt of acid. Okay, I hope you remember this. Let me well, I've done this entire information in my lecture, but let me solve this. Ethyl propanoate. So propanoate is this. Ethyl propanoate. So this is going to be the propanoate thing, ethyl thing. Okay. Now break carbon oxygen bond. You will get what? CH3, CH2, COO negative, Na positive because alkaline hydrolysis. So that's your salt. Plus alcohol. And alcohol is basically C2H5OH, which is ethanol. So again, B is incorrect. Acid hydrolysis of propane nitrile. Propane nitrile is basically CH3, CH2, and CN. When it undergoes acid hydrolysis, acid in the presence of water, obviously CN will turn to COH. If CN will turn to COH, you will get propanoic acid, which means C is going to be the right answer. Okay. Okay, ethane nitrile. So two carbon atom. This is going to be ethane nitrile. If you undergoes acid hydrolysis with it, obviously you will get CH3 and COH, which is your ethanoic acid. So examiner is looking for propanoic acid, not for ethanoic acid, which means D is also incorrect. 39. Lactite is an intermediate in the manufacture of synthetic fiber, which compound on heating with an acid catalyst to produce lactite. Look at this structure. This is ester linkage. This is ester linkage. We have two ester linkage, and according to my lecture, if you have one ester linkage or more than one, and you are hydrolyze it in the presence of acid catalyst under heating, obviously all the carbon oxygen bond needs to be broken. Okay. Now, according to the concept, CO will get OH of water and oxygen will get hydrogen of water. OH of water and oxygen will get hydrogen of water. Same here. This is getting OH of water. This is getting hydrogen of water. So what I'll do is I'll make the structure. This is CH3, CH, this is OH, and this is CWH. Okay. From here, this is CH3. This is CH. This is OH. And this is CWH. Now arrange the carbon atom. Apply the numbering of carbon atom. So carboxylic acid must be the priority group as compared to alcohol. It must be first carbon, second carbon, third carbon. So it must be 2-hydroxy propanoic acid. It is also 2-hydroxy propanoic acid. So 2-hydroxy propanoic acid is C. Therefore, C is going to be the right answer. By the way, we have 3 carbon atom, a carboxylic acid, which means it is propanoic acid. So it is ethanoic acid wrong. It is butanoic acid wrong. This is propanoic acid right. This is propanoic acid right. But the issue is OH is attached to the second carbon. So it must be 2-hydroxy, not 3-hydroxy. And therefore, C is going to be the right answer. Question number 40. My goodness, this is going to be the easiest question. In this paper, the diagram shows the relative abundance of the different isotopes of lead in a sample of lead ore. The abundance of 208 is half that of 206. The abundance of 208 and 209 are equal. Okay. So 208, 206 is 50% abundance. And 208 is 25%. And 209 is also 25% because examiner is saying the abundance of 208 is half that of 206. Okay. And also 208 and 209 have equal abundances, that is 25%. Let me take out the MAR of this. I've given you the expression for this. Mass of first isotope, which is 206, abundance of first isotope, which is 50, plus mass of second isotope into abundance of second isotope, which is 25, plus mass of third isotope, which is 209, into abundance of third isotope, which is 25. So divided by total abundance. So AR is going to be 207.25. So I believe B is going to be the right answer. That's the end of this paper, guys.